7.4, which is special right triangles. Now there's two special right triangles. There's one called 45, 45, 90 and one called 30, 60, 90. We are just going to focus on the 45, 45, 90 for today, and then the next lesson will be on 30, 60, 90. So with 45, 45, 90 degree triangles, I'm just going to try to erase without erasing completely. There we go. We're classifying this right triangle by its angles. There's two 45 degrees, and then there's the 190 degrees. Since these both are the same degree in these corners, the sides opposite of them are also the same. So this is actually considered an isosceles right triangle because both side lengths, both legs coming off the right angle, are the exact same length. So if this side on the left right here is 10, so is this side. And the cool thing about these special right triangles is that if both side lengths are the same, then the hypotenuse, the one across from the 90-degree angle box, is the side length, and then you're tacking on a square root 2. Of course, you can always resort to using Pythagorean's theorem and do 10 squared plus 10 squared equals hypotenuse squared. So then you get 100 plus 100. Let me write it out. So then you get 100 plus 100 equals, hypotenuse squared. 200 equals hypotenuse squared. You take the square root, and then you simplify that radical. Well, guess what? When you simplify it, it's going to give you 10 radical 2, which is exactly this shortcut up here. So it's saving you from not doing all of this. So if you can remember that whenever you see a 45, 45, 90 degree angle, triangle, that its leg lengths are going to be the same, and its hypotenuse length is always the leg length, tack on a radical 2. And 30, 60, 90 we'll come back to in the next lesson. So let's look at some problems together. So 45, 45, 90s. Good old 45, 45, 90s. First, we want to find the value of x and y. So we have to first identify which parts are the legs and which part are the hypotenuses. And for each one of these, I kind of highlighted where the legs are. Sorry if you hear that. I'm very bougie and I have a automatic litter box and it's cleaning itself right now. So let me turn it off. It's very loud. Okay. So I already highlighted or outlined what the legs are. They're coming off the right angle box. So this right here is going to be a leg. And this right here is also a leg because they come off of that 90-degree box. So that means if one side is 4, so is the other side. So x, that side length is automatically 4. Now we have to find my hypotenuse, across from the 90-degree angle. Well, this is simple. It's my leg length with a radical 2. Well, my leg length is 4. I'm tacking on a radical 2. That is it. It is that simple. So for example B, what is the x going to be? Yes, it's going to be 7 because 7 is the other side length. What about the hypotenuse? It's going to be 7 radical 2 or 7 square root 2. That's simple. This one, a little bit different because now I have a radical in my side length. So I just duplicate. All right, this is my side. My other side length, my other leg length must also be 2 radical 3. That's easy. But for my hypotenuse, I know it's my leg length times radical 2, right? Because when two things are next to each other, like in the previous example, it means that we're being multiplied together. So that means I have to multiply 2 radical 3 and radical 2. That's okay. This is kind of old school here, old material. If you have 2 radicals, they're alike. So really, I'm multiplying what's under the radical together and what's in front of the radical together. So this one has a 2, and this guy has a 1. And we don't show it because 2 times 1 or 1 times anything is itself. So it's kind of pointless to write a 1 there. So my blue multiplied together is 2, and my yellow, I get radical 6. So a little bit more math work than before, just a smidge, but not too complicated yet. All right, this is our next level of questions for 45, 45, 90-degree triangles. And it's called the next level because now I'm not giving you those leg lengths. We have to find them. So we have to work backwards. So here in my example in the teal, if I have my leg lengths, I'm just really, technically, I'm multiplying a radical 2 to the leg length. So to do the opposite, to go from a hypotenuse to a leg, I technically have to divide by a radical 2. So for example, D, if I want to go backwards to the leg lengths, which they're going to be the same because it's a 45, 45, 90, and I know because one of the angles is 45, the other one's 90, this one has to be 45 degrees. I can do the long way, which is actually writing out all the arithmetic. 2 radical 2 divided by a radical 2. Well, the special thing about radicals is you can never have one in the denominator. So in order to cancel out a radical, you need an exponent of 2. Or, you know what an exponent means? It means you're multiplying it by itself. So I'm going to multiply it by a radical 2. And what I do to the bottom, I got to do to the top. So now when I multiply these 2 radical signs are going to cancel out. And the 2 is going to be left on the bottom. Because really 2 times 2 is radical 4. And what does radical 4 simplify to? 2. That's the math genius behind it. So same nonsense up here. A radical 2 times radical 2 is radical 4. It cancels out to just be 2. So now I have this 2 in front. My new 2, a lot of 2's here. 2 times 2 is 4 divided by 2. So my answer, oh my gosh, is 2. Really? It's just the number. So if you see radical 2, it's the number in front of the radical. So x and y both equal 2. Yes, I did this long math, this long algebra for it to get my answer, but I didn't necessarily have to do that. If I notice that my hypotenuse in a 45, 45, 90 has a radical 2 in it, since radical 2 is in the shortcut, oh, I did not mean to do that, is in the shortcut up here, and it appears right here, well, x, the numeric value in front of that radical 2, is also the leg length. So I just need to take whatever's in front of that radical 2 and plop it or copy and paste it over into those side lengths. But in example E, that's why it's all starred, I don't have a radical 2, I have a radical 3. So now I do need to do all the algebra that I previously did in example D. So in order to work backwards and find the side lengths, I have to divide by radical 2. So let me write out the steps. 4 radical 3 divided by radical 2. The math god said, hey, no such thing as a radical in the denominator. You have to multiply it by itself in order to cancel it out. Don't know why I switched to blue when I want to switch to black. So in my denominator, radical 2 times radical 2 is radical 4, and the square root of 4 is 2. In my numerator, remember, you multiply your like terms. So 4 times technically a 1, and then radical 3 times radical 2. So I'm going to get 4 radical, what's going underneath the radical? A 6. Now I can look at this, try to simplify it as you go. Each step is important. Hope you're writing this down because it's very important to have a good example in your notes. This right here, 4 divided by 2, I can simplify that to be what? 2. And then this radical 6 gets copied and pasted. So my answer for x and y is 2 radical 6. So the difference between example D and example E is the sheer fact that in each hypotenuse, if you have a radical 2, super simple, take the number in front of the radical, and that's your side lengths. But in example E, my radical had a 3 under it, which means I have to do a little bit of arithmetic to find out what the side lengths are. Example E is probably the hardest you're going to see, in this class at least. All right, so we're going to try. I'm going to rapid fire questions at you. For number 1, what is the value of x and y? It's 45, 45, 90. You know because both side lengths are the same, and there's a 90-degree angle box, so we can assume that these both are the same. So x is 6, and y is 6 radical 2. What about number 2? Find x and y. X is the same side as the other one, 2 radical 3, and y will be 2 radical 3 times radical 2, which is 2 radical 6. Number 3, find x and y. So x and y are the same length, and they're both going to be 7 because I'm backtracking, so I have to divide by radical 2. But look here, there's a radical 2 here already, so that means I can take this number in up front, and it is the same on both sides. Or if you chose the path of least resist or most resistance, I should say, I'm going to divide by radical 2. Math gods say, hey, no radicals in the bottom. Multiply it by itself to cancel it out. I get 2 in the bottom because remember this means radical 4, which simplifies to 2. Up here I get 7 times 4 because again, this is radical 4. Oops, sorry. Which simplifies to 2. So it's 7 times 2. I get 14 over 2, which is 7. So a lot of work, a lot of algebra right here to just get the number in front of the radical sign right here. So avoid this work when you can. All right, the harder problems. What are the side lengths for number 4? All right, I got to divide by radical 2. The gods say, heck no, no radicals in the denom. Multiply by radical 2 to cancel it out. Radical 2 times radical 2 is radical 4, which simplifies to 2. I can only say that so many times. Up here, I get 47 radical 6. Now, the only thing I can see is if 47 is divisible by 2. Let's see if it is. 23.5. So I can't really simplify it. I'm going to leave it as is just because fractions I think are a little bit more precise than decimals. So my answer is 47 radical 3. Oh, can't speak. It's getting late. Radical 6 over 2 for both of them. How about last question? Last question of the day. See, then it goes in the next one. What are the leg lengths for number 5? 64 radical 5. I got to divide it by radical 2. Math gods say, heck no. I get 2 in my denominator. And up here, I can only really combine 5, radical 5 and radical 2. So I get 64 radical 10. All right, can I simplify? Yes, I can. To 32 radical 10. So both these x's, because they're both the same, are 32 radical 10.